Hey everybody, welcome back. Okay, so this lesson may be one of the most important lessons that your kids could learn. It will be used over and over again in all future math. So please feel free to look at this more than once if your kids are ever struggling. Might even want to bookmark this one. We're going to talk to you guys about the addition property of equality. It's the ability to add the exact same rational number to both sides of an equation and get an equal equation. Basically, we're saying that if x equals y, then if we add z to both sides, it will still be equal. Let's see what this means. Okay, here's a very simple problem. X is a variable. We don't know what x is. So a number I don't know plus 6 equals 9. What's the number where we don't know? Hopefully you said 3. Okay, so let's see what this problem looks like. I have a number I don't know. I have 6 added onto it, and both of those together equal 9. Notice these two distances are the exact same thing. So I like to say that when solving equations, the goal is to isolate the variable, or get the variable by itself if I was speaking to second graders. How do I get the variable isolated? How do I get the x by itself? Well, it's simple. I have to take away the 6. Watch. If I take away the 6, the x is by itself. Pretty simple, right? But are my lines equal anymore? No. Whatever I do to one line, I have to do to the other. And that's what keeps things equal. So what did I do? I took away the 6 from both sides. Take away. What does take away mean in math? It means subtract. So notice, what did I do? I subtracted 6 from both sides. On this side, I ended up getting 6 plus negative 6, which is 0. X plus nothing is just x, as you can see, and 9 plus negative 6 equaled 3. And that's why we know that x equals 3. And this is everything that I want you to be able to know from this lesson. That's it. Seriously. So, how can we use this? Here's another look at the problem. Notice, if I used a scale, I know some people like that. I've got a number I don't know plus 6 on this side, and I've got 9 over here. So what's our number I don't know equal? Well, what if I took 6 away from that side? Notice, it would not be balanced anymore. If I wanted to be balanced, I would have to take 6 away from this side. Now it's balanced. Notice when I took 6 away from both sides, it stayed balanced, and I get x equals 3. Some of the mistakes that students will make is that they will only take 6 away from one side. If you only take 6 away from one side, hopefully you can notice the scale is no longer balanced, because we know x does not equal 9. That is wrong. All right. What if I took 9 away from one side? And everyone, I'm going to have to fix this. There should be 3 more blocks here. What happened? Okay. So if I take 9 away from that side, hopefully you're noticing it's still not going to be balanced. Heck, it's not even balanced now with the 3 that I had here. The variable is not isolated. It's not by itself. So again, it's not balanced, and you are wrong. Okay, so let's see. How can I solve this without pictures? Well, I know that if I'm going to be isolating the variable, all I have to do is take 6 away from both sides. If I take 6 away from both sides, I end up getting what's called a 0 pair, and x plus 0 equals 3. Basically, x equals 3. You will see this a couple of different ways. I know some people who like to go sideways. Horizontal, for the fancy word. Notice, once again, I'm still subtracting 6 from both sides. I just have a 0 pair that is horizontal instead of vertical. Once again, I get x plus 0 equals 3, which means that x equals 3. Another way you may have seen is people like to do decomposing. So if you break apart the 9 into 3 plus 6, it makes the problem very intuitive because notice, a number I don't know plus 6 equals 3 plus 6. Well, duh, 3 is going to be the number that means that I don't know. And if I subtract 6 from both sides, I'm just going to have 0 pairs on both sides. So I get x plus 0 equals 3 plus 0, and we know that x equals 3. I like this way. It's very intuitive. However, you can notice this set steps are longer than these steps. So use this to understand, and you may want to switch to one of these just to be able to go a little bit faster. Once again, if you check, 3 plus 6 equals 9. Okay, so here we are. What if I switch it up? I put the variable on this side of the equation, because notice here's x plus 6. And look, here's 9. So, what do I do now? Well, I still have to take away the 6. Doesn't matter if the variable's on the other side of the equation. Hopefully you can see I have to take away 6 from this side. And if I take away 6 from that side, I have to take away 6 from this side. So I do the exact same thing. X equals 3. All right, if I have variables on the right side, once again, how do I get the variable by itself? Well, what I do, I subtract 3, and then I subtract 3. Whatever I do to one side, I have to do to the other side. That's what keeps it balanced. And x plus 0 equals negative 7. There you go. What if I do it the other way? Well, notice I just go side by side. Look at my 0 pair. I still get negative 7. And of course, can I decompose? If I'm really good at it, I can. Because negative 4 would equal negative 7 plus 3. And I get my answer. Notice how this was not quite as intuitive as the previous problem. Okay? But give it a shot. It really does work. Now, one of the rules that you're going to learn is that anything we've learned in math for regular numbers, regular integers, also work for our rational numbers, our fractions, our decimals. So think about this. I have x plus negative 4/5 equals 1/5. So how am I going to isolate the variable? Well, I do it the exact same way I did it on the previous problem. How am I going to get rid of the negative 4/5? Well, I'm going to add its opposite, positive 4/5. Notice negative 4/5 plus positive 4/5 equals 0. And now I'm just left with this problem. 1/5 plus 4/5 equals 5/5, which equals 1. Can you solve this one? Did you subtract 7/9? Did you notice the 0 pair? Do you understand how this takes a little bit of practice? And yes, we will be practicing this lots. It's one of the most important steps in algebra, so we will make sure to practice it lots. Once again, now I just have to be able to solve this problem. I get negative 4/9, and that's what x equals. Like the sound effects? You guys. Okay, I'm back. Did you subtract 5/11? Did you get negative 12/11? For the official record, I will accept this answer, and I will accept this answer. Okay, now I showed you there's more than one right way to be able to do a problem. Once again, some people like being able to go vertically. Don't be afraid to do the work off to the side. Far too many students will try and do this problem in their head. They will get the wrong answer. Please make sure to always do your work off to the side. Get your common denominator. And then put your correct answer in. Once again, I do know some students who will like to go side by side, horizontally. Once again, do you notice we have the exact same problem, 1/3 plus 4/5? And you would get the exact same answer. All right. And if I have subtraction, what do? I turn every subtraction problem into an addition problem. Are you starting to see how all this works together? Boom, boom. And now, how do I undo a negative 1/3? Or how do I eliminate the negative 1/3? I have to add its opposite, positive 1/3, because negative 1/3 plus positive 1/3 equals 0. Once again, this problem, please do it off to the side. And I get the answer. 1 and 1/12 would also work for me. All right, what about mixed numbers? Can we do the exact same thing? You betcha. I turn every subtraction problem into an addition problem. And what am I going to add to both sides? Did you say 5 3/5? Because that equals 0. And now, once again, do not be afraid to do this prop work off to the side. I end up getting 6 27/20, which would get me 7 7/20. All right. So whatever works for regular numbers, works for fractions, works for mixed numbers, and you guessed it, it'll also work for decimals. What am I going to add to both sides? Did you say positive 6.88 or 6 8800ths? Once again, do not be afraid to do this work off to the side. One's negative, one's positive. We're going to subtract these numbers. So I put the 6 8800ths on top, and I subtract the 5 6600ths. Line up the decimals. Notice how I get my answer. Since the larger number was positive, the answer is positive. And I really hope that you noticed that the rules for algebra never ever change. The addition property works for integers, rational numbers, variables, you name it. Once you master this step, you'll be able to use it the rest of your math career. Do not be afraid to come back and check out this lesson more than once. Yahoo! I have no idea what that was. However, did you think to add positive 5 and 1200ths? Because now I can just add them up. Apparently I have lots of sound effects in this lesson. All right, last one. What are you going to add to both sides? Did you pick negative 7 6/10? Awesome. Now, positive, negative, so I'm going to subtract these numbers. The larger number is already on top, so how can I subtract? Well, if you want to, don't forget to put in this extra little 0. Makes it a lot easier. And you get your answer. Okay, if you got any questions, please make sure to let me know. And you guys have a great day.